So I'd done research on small farms for several years. And then if we jump ahead in time, we get to 1994. And I had just come back from more research in Nigeria and was writing an article about population and small farming and conflict. And I remember taking a break from my work to walk down Broadway, and I went into a greengrocer's there and saw something called a Flavorsaver Tomato being sold, and it was advertised as a genetically modified tomato. And I didn't have a clue what to make of that, and I remember being scientific about it and buying a genetically modified tomato and also a regular tomato and bringing them back to the apartment and slicing them up and doing a taste comparison and thinking there wasn't that much difference, and then not thinking much more about it for a while. But that was the beginning of genetically modified foods and crops. That was the first genetically modified food that had ever been sold in the US. And what happened in the years following that was that more and more genetically modified crops were produced and more genetically modified foods were being sold. And by 1996, genetically modified foods were coming into the European markets. And by 1997, there was a big backlash against them. And by 99, the companies that were involved with these, which includes Monsanto was the dominant one, but several others as well, realized they had a major problem. And they took a step back and regrouped and said, how are we going to rethink how to sell these products? And so by 99 and 2000, this whole narrative started to emerge that had to do with the third world, and it had to do with these crops are really, or these foods are really what is needed to feed the third world. And this led to just a huge brouhaha that was played out in the academic literature and on television and in the press and in paid-for media by public relations companies. And people were going back and forth arguing that no, these new crops actually are endangering people in developing countries. They're not needed to feed people. They're not tested. They're not safe. They're leading to corporate control over food. Versus the other side arguing that no, this is science. This is progress. These are technologies that can make safer foods and more productive foods, and so on and so forth. Basically, there were a lot of claims being made about how these technologies would affect farmers and would affect the consuming public, and there was almost no role in the debates for people who actually studied those things. So I actually studied small farms, which were one of the big things that kept coming up in these debates. And I was able to work in a biotech lab to try to get some sort of firsthand experience and knowledge of the way the whole process worked, and also started looking at developing countries where genetically modified foods and crops were either available or looked like they were going to be available before long. And India turned out to be far and away the most interesting place to me, where there seemed to be a need for some genetically modified crops there. And at the same time, there was a very active NGO sector, that is a green activist sector, who was all geared up to fight genetically modified crops. And I've been going back every year since 2000 and studying the cotton farmers there. Cotton was the first GM crop that was going to be released there. And so I was there for 2 years before the GM cotton became available. And then in 2002, GM cotton became available, and over the next several years it grew very slowly in popularity, and by about 2005 it was starting to become very popular, and it now is completely dominant in the whole cotton sector there. There are claims in India that are made on a regular basis that not only aren't true, they simply couldn't be true. The classic one, the most hotly contested one, year in and year out, is the argument that has to do with suicides, because India has got a really tragic problem with farmer suicides. And the argument is made routinely by some scholars, by lots of activists, all the way up to Prince Charles has opined on this. Not that he is exactly an expert on biotech or causes of suicide, but the argument is made over and over again that it is the failure of this genetically modified cotton, this BT cotton, that is leading to all the farmer suicides in India. And just the historical fact of the matter is that the biggest spike in suicide, farmer suicides, by far was in 1998 in Andhra Pradesh, which is the state where I work. And that was 4 years before the biotech. That was 98, 99, 2000. Yeah, 2002 was when the GM cotton was first released. So it simply couldn't have been the cause of it. And furthermore, since then, the data do not show that in general there has been more failure of cotton crops. Some cotton crops do fail, but some cotton crops failed before BT cotton came along. Biotech, when BT cotton first started to be tested in India, the story that was coming out of the activists at that time was, beware of this stuff, these crops are Terminator crops. And Terminator was the nickname given to a technology developed by a cottonseed company, actually originally developed by the USDA, but co-patented with a cottonseed company in Louisiana, that would make, if it worked, it would make seeds that couldn't be replanted. The farmer could buy the seed, they could plant it, they would get a crop, but the seeds could only be sold, they couldn't be replanted. So this struck a lot of people as a very offensive use of biotech and sort of an anti-farmer technology. So the technology really was patented, and it was out there, although it hadn't been commercialized. And people were mobilized in India. They were out having marches against these new Terminator crops. But they weren't Terminator crops. In fact, there's still, to this day, there are no Terminator crops. It is just an experimental technology. There are no Terminator plants anywhere except probably in a greenhouse in Louisiana. I think a lot of it, I tend not to want to talk about things being good or bad in general. I tend to think of them, are they good for a particular party or for a particular interest? So I think biotech is good for a lot of interests, especially in the U.S. It obviously is good for the biotech sector. It's great for intellectual property lawyers. It's very good for a lot of universities because it gives new grounds for corporations wanting to sponsor a lot of research there. Oh, also in terms of farmers, there are some benefits here for big commodity farmers. There's no doubt about it. But in terms of these claims that have dominated the debate since the late 90s, the idea that this is going to be a key technology for feeding the third world and for helping third world farmers, I'm much more skeptical on that claim. I think there are a few projects underway with genetically modified crops that I think do stand to offer farmers unique benefits. And the one that I've written about and I still think is probably the most promising one is there's a project going on at the Donald Danforth Plant Science Center in St. Louis where they are working to make cassava not only resistant to viruses, but also biofortified, that is, having its nutritional content enhanced. And I think there's specific reasons that that could be a very beneficial crop. Cassava is a great crop for the poor. It grows really well on poor soils. It's not really finicky in terms of its labor requirements. So if you're a poor farmer and somebody in your household's sick and you can't mobilize a lot of labor, you're probably not going to lose the crop. It's a multi-year crop. You can plant it 1 year and continue to harvest it. It can be used both for subsistence and for sale. So for a lot of reasons, it's a really good crop for the poor. And it does have some really severe problems. Nutritionally, it's quite poor, and it's being devastated by some viruses in Africa. And on top of that, it's a really tough crop to improve through conventional breeding. It's not going to be end up under corporate control. A farmer can cut a twig off and give it to their neighbor, and they can plant that, and they can have a cassava plant. I tend to be pretty impatient with the general arguments that people are starving in the third world, therefore we need genetically modified crops. Because we've seen this over and over again, that when people are hungry and malnourished in the third world, it is virtually never because there's not enough food. It's because they're too poor and they can't get the food. And this is so clear in India today. India has got more hungry people than any other country in the world by far. There's not even a close second. And India's, their buffer stocks of wheat and rice, they've got over 30 million tons beyond what they can even store in their buffer stocks, in the public buffer stocks. There's plenty of food in India. And so when people make the argument that we need GM crops to feed the third world because they're hungry in India, my question has to be, you've got to explain to me what GM crop is going to feed hungry Indians when 30 million tons of excess wheat and rice can't. You have to remember that this issue changes depending on which crop you're talking about. Rice works differently than cotton. It changes depending on what area of the world you're talking about. Kansas and the Punjab are very different. It also varies through time. And so I would be very hesitant to generalize too far from what I've seen. But that the Indian cotton farmer was in big trouble even before BT cotton came along. And people have argued back and forth about what the problem was. And I've looked at this pretty closely for the last 10 years now. And I think the core problem, the most central problem they faced, was that this cotton seeds on the market, and they've got hybrid seeds, hybrid cotton in India, which means the farmers have to go back and buy it every year. So it's not one of these cases where the farmers can replant their own seed and develop their own locally adapted landrace. The seeds that the farmers were buying changed very quickly. Every year there would be a whole new series of brands on the market. And they also were pretty unreliable. The cotton sector is, the seed sector is regulated very poorly, and a lot of seeds are mislabeled. And, the whole process, what I call the skilling process of figuring out how that technology works on your farm, that process was broken down. But what I'm concerned with is that at the cost of some added insect protection, what farmers have had to deal with is even more rapid change in the technology and even more unrecognizable technologies. When the BT cotton first came out, there was one genetic construct in it, and there are now 4 different genetic constructs. In other words, 4 different gene setups in the cotton. And none of the farmers that I've talked to really understand what the 4 different genes are all about. None of the vendors can explain what they're all about. And in fact, the scientists don't even know exactly how the 4 different gene constructs perform. I think probably in general the farmers have accepted a tendency for the cotton to work a little bit better at the expense of an exacerbation of the underlying problem. And the underlying problem is that the technology is too unrecognizable, it's too opaque, and it's too rapidly changing. One of the things that's endangered here is the farmer's sense that they know how to run their farm. And in some of the people who write on this, especially from the biotech industry, you get this sense that, well, the small farmer doesn't know what he's doing or what she's doing anyway, and so if we can come up with a technology that works automatically, then that's a win-win situation. But from my standpoint, that's sort of a win-lose situation. When you introduce a technology that seems to solve a problem automatically, taking it out of the hands of the farmer, that's great as long as your solution always works and keeps working. But what if your solution stops working? Now might not the farmer be in a worse situation than they were to begin with? And these things do stop working. The 2 technologies that completely dominate the world of GM crops are insect resistance and herbicide tolerance. And the insect resistance comes from putting in a Bt gene, and for a while it makes it so that it will kill certain categories of bugs that eat the plants. But the bugs always are going to develop resistance. And in fact, that's happened in several places in the world now, and it's happened in India. And we're now starting to get the first signs of resistance. And that's been the people to announce it, in fact, were Monsanto. They said we're starting to get resistance. And so Monsanto's solution to that is, no problem. When resistance comes along, we've got wonderful things in the pipeline. We'll have another genetically modified plant to back that one up, to replace that one next year. And when that one stops working, we've got another one after that. And so from their standpoint, I could understand that it looks like a winner, it's going to be a moneymaker, and from their mindset, it's an exciting thing. They're out there solving farmers' problems. But from the farmer's standpoint, a lot of the problems they're solving were the ones that Monsanto created in the first place. The farmers end up being on a treadmill. And so their own ability to deal with those bugs, whether it's by shaking them off like you were talking about, or by using all sorts of other low-tech solutions, they tend to lose those abilities. And so the farmers in India now are on what they call the pesticide treadmill. And the claim is that they're just gonna trade in the pesticide treadmill for the genetic treadmill. From my observations they're now on both treadmills. They still have to keep using insecticides, and they're also becoming increasingly reliant on genes. And as the genetic technologies lose effectiveness, then they're reliant on a new genetic technology. So it's a continuing area of research for me. But at the same time, I've maintained an interest in small farms in America, and so the other research interest that I'm developing now has to do with a startup research project that has to do with a whole new wave of small farmers in America. Sustainable farmers, organic, local marketed, humanely raised, pastured, direct marketed, so on and so forth. So it all has to do with farms, and it seems to all have to do with small farms. I'm not interested in big industrial agriculture so much, and that's how I got to do it. In the U.S., I am really quite interested in the surge of interest in new kinds of agriculture. And there's not even a proper word for it. Sometimes it's called New American Farming, but it's not just, part of it's organic farmers, but it's not just organic. Part of it is small scale. Part of it is direct marketing, so farmers that show up and sell their things in the local markets. Part of it is humanely raised. It's the farmers who want to have their chickens and pigs and cows raised humanely as opposed to in CAFOs, so on and so forth. So one of the things that is essential in this sort of new American farming is that the skill, farmer skill, has to come back into it. What makes sustainable farms actually work? Skill. Skill is an absolutely essential part of sustainable farming. On one hand, it's true that universities have long had financial entanglements with the corporate sector. And I'm sure that if my friends from Monsanto were here now, they would say there's really nothing new about this. Universities need money from the corporate sector, and one of the things that the universities are supposed to be doing is benefiting industry as well as society at large. One of them has to do with patents. When people started genetically modifying crops, or genetically modifying organisms in general, it ended up playing a key role in changes in patent law. And so patents are now awarded on genes, or technically on the use of genes in biotechnological inventions. And the majority of these patents are held by companies. And Monsanto has got a very large and lucrative portfolio of these patents. And so in order for researchers to be able to use those genes, they have to be able to get permission from Monsanto. So this gives, and it's not just Monsanto, it's a lot of biotech companies, so this gives them a new way of influencing the sort of research that gets done. So much of what drives biotech is innovation and basic research. It's a very research-intensive field. And so universities are in the research business. And so I think the economics of it make for new emphasis on universities seeking funding from companies like biotech companies. I have felt relatively free to do the sort of research that I want to do. On the other hand, most people like me, social scientists, we're not going to have findings one way or the other that would be of that much interest to the biotech industry. So they're not inclined to fund us. And it's not especially likely that we would be publishing things that they would find especially annoying or embarrassing. I think what a biotech company would do is if a social scientist was coming up with those sorts of findings, rather than putting pressure on them directly and trying to keep them from doing their research, which would be really hard to do, there's no direct route for them to do that. A more likely way for them to respond would be to try to marginalize or to cast doubt on that person's research. And there's a long history of companies being able to cast doubt on research that is embarrassing to them. The case study in this is the tobacco industry, which for years managed to turn absolutely indisputable evidence of the ill health effects of smoking into a question. You know, some people think it does and some people think it doesn't. And so there's a famous phrase that came out of all that saying, doubt is our business, or doubt is our product. So they can create doubt. So I think that if I were to tomorrow find that actually GM cotton in India is, as you say, making the rich richer, making the poor poorer, it's actually an economic disaster, it's not solving agronomic problems. And if this were to be published in some high-profile place, what I would expect the biotech industry to do would be to simply cast doubt about it. And